Okay, so welcome back, everybody. It is our second week now. We have a pretty full list of things to cover today, but I hope you're ready to get started. I'm gonna go ahead and share my screen, and then we'll walk through what we're gonna be doing today. So as a reminder, last week we did some one-on-one stuff. So we'll be talking a little bit about what folks worked on and what questions they have and that sort of thing at the start of class. Today, Leah is gonna be covering sort of what deep learning models look like and what deep learning networks look like. And then we'll use some examples of DeepDream, which I think will be pretty fun and maybe help. It certainly helps me sort of understand how DeepDream works. So I think it'll be fun to see that. And then I'm going to cover some inspiration materials, because I know that one of the things we saw in our class survey was just that people were looking to sort of find cool examples of things and get inspired. So I'll show some things, and then I'll also cover how to move a model that you find on like GitHub or something into Colab. So you know, maybe you found a model that isn't listed in one of our repos, and you want to figure out how to convert it. So I'll cover a little bit about how to do that. So I think next week we'll send out Calendly links so you can set up one-on-one time with Leah and I. And I'll also note, I know we posted it kind of late on Friday, but we're going to do co-working and Q&A times at Saturdays, 3 to 5 my time. So whatever time that ends up being for you. So that's probably what this is like an optional time. You're welcome to stop by, ask questions. Some people stop by and listen to other people's questions just as a way to sort of learn more. It's completely optional. No one has to show up. But I do find that it helps if you have specific questions you want answers to, that this is a good time to sort of come through, because you know, I think yesterday we had like maybe 4 or 5 people show up, which meant like, you know, I could give 15, 20 minutes to each person to really answer questions. So it's a nice moment if you can attend. You're always welcome to DM Leah or I if you have other questions, or post in our Slack channel. So that's always an option we want to make. Like, I know that this time might not work for everybody, so we can work with you however you need to, but it's just a nice time to sort of set aside some time and ask questions if you have any. And obviously, like it being on Saturdays, maybe you've gotten the whole week to sort of work on stuff, so you should hopefully have some questions. So today, we'll do a little bit of discussion on homework. Leah's going to do a demo, and then we'll do the inspiration and the creating a notebook discussion, and then we'll save a little bit of time at the end, hopefully for Q&A. I like to do like 5 to 10 minutes of Q&A, just because people sometimes do have immediate questions, but otherwise we'll save Q&A for either a co-working session or for Slack. So I'm interested to hear, actually I shouldn't even do this because I'm going to share my Slack channel. How did people feel like this week went? Was it helpful to sort of play around in Colab? I know I heard from a couple folks that like it was sort of nice just to sort of get their feet wet and like sort of like learn how Colab works as a system. But I'm also interested to see if anyone, does anyone want to share any of the work that they made? I can go through Slack and call on people otherwise. Go ahead, sorry.
I posted my test of SynGAN on Slack.
Yeah.
And so Derrick and I, we talked about it yesterday, but the couple things that I ran into was I wanted to see how it would look at a larger output scale as opposed to the standard 250, which I know runs faster. And as expected, Colab completely shut down on me overnight. And I got that like runtime or like disconnected due to inactivity message a couple of times even throughout the day. So yeah, that was definitely frustrating to like wake up to that. And also I wanted to try out the deep sort, the one where it like detects objects and people. But like I was reading through there, I feel like it's not as well documented as the SynGAN, obviously because I know SynGAN was used for classes, but I couldn't figure out where to put the input video, even though it said like change the URL here, or like reading it through was like, okay, like I thought I was just swapping it out, but it just kept giving me errors, so I couldn't do anything with that. So definitely, and also I don't know any Python. Like I can kind of understand JavaScript, but other than that, it's very much just trial and error, being like, okay. So maybe if I knew the language, or if I at least knew the basics of it, it would be easier.
Yeah. Well, first off, sorry that happened. I'm happy, like Lee or I could probably go through this with you and maybe try to debug it. I also have not used this one before, so it might, sometimes like what you find is some of these are actually just straight up broken, and like no amount of trying to mess with them is going to fix them, which is very frustrating in and of itself. But that's sort of like, this is the wide world of using GitHub and a lot of these deep learning models instead of being in Runway, where hopefully someone has checked to make sure they all work and are up to date. But yeah, I think one of us could probably go through it with you and maybe try to figure out what's going on there. To your first point of runtimes disconnecting, that sort of thing, that is the most annoying part of Colab for sure. And I know you and I talked about like maybe ways to mitigate that or ways to at least help with that. And we'll look at that again more next week. I know I talked to a couple other folks about that as well, which is we'll look at using Google Drive to sort of save our work while the process is happening. So right now with a lot of the notebooks, what you'll have to do is you have to run them. When they're finished, you're going to have to hopefully know immediately when they finish and move your files, either download them or move them to Google Drive. Because if you're not on Colab Pro, I feel like there's like a 5 to 15 minute window where if you're not active, Colab is going to shut off your runtime. With Colab Pro, I think you get like a little bit of a longer time, but even with that, it's still like not still not a short period. It's still not the longest period of time. So what will happen with Google Drive, and we'll go over this in more detail next week, but basically if you like load your repo into Google Drive and then you save your results into Google Drive, it's saving in the files as your runtime is working. So when your runtime disconnects, all your work is already saved into Google Drive, which is a lot nicer than having to like constantly monitor your tab. So yeah, definitely the biggest, most annoying part of it. I'll also say that Syngan in general is kind of an annoying library because it just takes a while to train a single image, right? Like you wouldn't expect a single image to take this long, but it does. And that's sort of a limit of Syngan as a whole, and honestly why I don't teach it very often, even though I do think it's like an interesting library. And I think this result here like sort of shows how it is pretty cool. Yeah, so it's like one thing to know is just like some of these models are also just straight up annoying as in and of themselves. And I think that's also why we tend to see people tend to gravitate toward things like StyleGAN or Style Transfer, these other like sort of big libraries, because one, they're really well documented, and two, they just tend to work like fairly stably. Whereas something like Syngan, I think I saw a lot of people get excited about it and then they sort of realize like that it takes a while, it's hard to get high resolution images out of it, those sort of things. So there's actually a new version of Syngan that is called ConSyngan that I've played around with a little bit, and it's definitely faster, but I didn't like the output results as much. So depending on how much time I have this week, I might try to throw that in a notebook and just sort of see if you'll find that more interesting to them or whatever. So thanks, Naoko. Anyone else want to talk about their stuff? I'm happy to talk about your work if you're not. Okay, I'm going to talk about Peter's video here.
Yeah, I mean, I can ask
Okay.
because, well, so yeah, I also had like the issue of looking at a few different, of like the notebooks, but not really being able to find, or just like not being able to work it, like the PIFU one. But for this, I was interested what you train this, pretty much like, I don't know what a pickle model is, and I guess we could like, let's watch that today when we talk about models, so maybe it's not worth going into right now, but it's like, I don't really have much except for adjusting some of the arguments in terms of like the length and like the steps for the latent and like the constant layer. I didn't have much like input into, like I wasn't inserted, like there's no image I was giving it or video, so I was kind of curious like what you trained this on, and then also like how I'd be able to adjust that the output more, just if I'd have to like train a model, or if that's like what that looks like.
Yeah, that's a great question. So we'll talk a little bit more about this particular model, probably, or this particularly this particular notebook probably in the last week of class. But just to give you like, yeah, just sort of the high level view, and maybe we can link to some StyleGAN videos that Lee and I have done in the past, just to help people that are interested in that topic. Basically, this is trained on a series of abstract art images that I found off of Instagram from an artist named Freya Buckler. So basically, you train that. The training process for StyleGAN is pretty intensive and will definitely take you a long period of time. But basically, once you've generated that, you generate a pickle model, which is then, and this is sort of what Leah will go through, is like, it's just got a bunch of layers in it. And those layers, you feed it like a very, what's called the constant layer, which is what you're manipulating with flesh digressions. That is like almost like a noise channel. It's just like a list of numbers. That list of numbers goes through this network and it's able to produce an image out of that. It's like hard to talk about it. And I think Leah's like the demo will cover a little bit more, but essentially it just uses what's called convolutions and these layers to basically build up an image from. So what this does is this sort of manipulates that really early layer and it manipulates the very end layer. And by doing those two things in tandem, you get this like kind of like interesting little video. One thing I'm really interested in this one is that there's faces in all of these, and like I've never seen faces in this model before. So I actually have no idea. I like kind of know what's going on in this, in that the sense that it's like this was trained from a model that initially was faces. So it seems like faces got stuck in some like weird corner of this model, but I've used this model, which is one of mine, like probably like hundreds or thousands of times, and I've never seen faces in it before. So I'm really, really interested in what happened here. So maybe you just found like the right numbers and tweaking those numbers to get an interesting face out of this, or to find like whatever that, yeah.
Well, so is that like StyleGAN 2, like initially is trained on faces, right?
Yeah, most of us will use what's called transfer model, and we'll start from the faces model, which exists in, which is like one of the ones that NVIDIA, the people that made StyleGAN 2 built from. So what that means is that usually when you're transferring, most of the time it completely obliterates the entire model and you never see anything like faces in it. But what it also means is probably somewhere deep in that network, in the very corners of the latent space, are things like faces because it's been previously trained on there. But this is really interesting. I've never seen this happen before. So kind of interesting. Yeah, so if after like Leah's demo or after we talk more this week, if you still have questions about pickle models, I'm happy to answer other questions.
I have a quick question regarding this specific model. Is this the one that was originally trained in Runway? Or did you retrain it or like
yes,
manipulate it in Colab afterwards?
So this one I did train in Runway, and then I trained on top. I kept training it a little bit longer on my own servers. Yeah, so this was one that was trained on Runway initially. Okay, cool. Because I know we want to keep moving, I'm going to quickly touch on a couple other little things that we talked about in our co-working session yesterday. So a couple of things that I clearly didn't mention to you, but I should have, because I know these things exist and I just sort of like, you know, after you do this for a while, you sort of forget. One thing to note is that if your machine goes to sleep, then so does Colab. So Colab is sort of one of these things where like, if you close the browser tab, or if you quit Chrome, or if you like shut your laptop, if there's no connection between your laptop and the Colab notebook or the Colab server, Colab will shut off. So just know that like you probably need to set your machine to not go to sleep if you're doing a longer process, those sort of things. So sorry if I didn't mention that and you had something processing and it shut off on you. A second thing, and let me actually just, I'm gonna move out of this again and just sort of show the example here. So Naoko and I found that one of the things when you open a notebook for the very first time is a lot of times you see like, so this is the SynGAN notebook, right? And when you open it for the very first time, you see all these outputs like underneath the code sample, right? This is what's called an output or a log. And what happens is that it saves it saves whatever, like, so basically when I made this notebook and I saved this out, it saves your output and logs to the notebook. So the first time you open this, you're actually gonna see like what ran on when I ran the session, right? So what kind of happened here, and it's not anyone's fault, it's just sort of funny, is that somewhere at the bottom here, there were a bunch of error messages. And so of course, you know, Nowco like looked at this and said, oh, I have error messages in whatever I'm running. And this is, you know, this is just something to know, is that like when you first open a notebook, you will see other people's outputs. So there's two things to do here. One is just remember like that obviously your outputs are not, or like the outputs that when you first open this machine are not for you. But another thing you do if you just want to like help clear your head and like also not have a bunch of gobbledygook in your notebook is you can hover over this little person icon here, and you'll see that it gives you an X. When you click that button, it's going to clear all that output. So like one thing you could do whenever you open a notebook for the first time is just come in here and just sort of, you know, clear out all of these outputs. I probably should be doing this before I save notebooks, but sometimes in a hurry and sometimes I forget. But that's an option. That's also something you can do while you're training. So if you've run a couple of these things and you just want to like sort of clear the screen a little bit more, you can clear those outputs. So I definitely recommend like maybe just doing that as you walk through a notebook, and just to like sort of make sure that you're not seeing error messages that aren't really for you. Let's see, a couple other little notes. So a really important one, which again sort of like skipped my mind, there are 2 links here. Man, I'm really doing a bad job of jumping back and forth here. So there's links about saving a copy in Drive, save a copy in GitHub Gist, and save a copy in GitHub. One really important thing to note is that what you're saving is the notebook. So in the case of like, if you have files and other things here, you are not saving those files, you are just saving this notebook. So if I go and hit File, save a copy to GitHub Gist, all that got saved here. Oh, interesting. Okay, that didn't do what I expected. I thought it was going to show me what the code was. But anyway, all that happens there is that you just get the code that runs this notebook. So it's just like these text cells and these code cells. So just beware that like you can't actually save, like if you produced images using SynGAN or something else, you can't save them using just file save. So if we have a little bit of time at the end of class, I'll go through like how you would actually sort of save those materials. There's a couple things you could do. What Nowco and I ended up doing was just zipping up a bunch of files using a zip snippet to make a zip file. Or the other option is to just go over each individual file, click on the little ellipses thing here and hit download. Your other option is to save, or is to do a Google Drive mount, and then to drag your files into Google Drive, and that will save them into Google Drive. But it's important to know that like, if you don't save those files and your runtime disconnects, you will lose those images in those files. So sorry if that happened to anyone, but just, yeah, be aware that like these 2 functions, these save functions, just save the notebook. I'll cover a little bit more about pre-trained models at the end of class, but I know someone asked, you know, in the case of something like StyleGAN2, where do I go to find pre-trained models? Or if I'm opening up a new model in like Google Drive, or sorry, in GitHub, how do I know what the pre-trained model is? And that's a challenging question that can differ from model to model. I'll cover a little bit of that maybe when we talk about converting notebooks. In the case of StyleGAN2, there's actually a couple repos of people who have just saved, who are saving and collecting a bunch of StyleGAN2 models. So I'll link to that resource as well. And we'll talk about that more for sure in week 4 when we go over StyleGAN2 notebooks, because that'll be a pretty common thing for us to do, is grab someone else's model and work off that. And as I mentioned previously around saving, Google Drive is your friend. It is especially helpful during training where you are likely going to just run a notebook for as long as you possibly can before your runtime gets disconnected. So in that case, you want to make sure that you're in Google Drive and saving work to Google Drive as you process. And we'll cover more of that next week. And I will probably record a video this week to just go over those steps just so people have them. Any other big questions from this week's homework?
Not a question, but just talking about clearing out the outputs. There's a menu item under edit for clearing out all of them at once, so you don't have to go through and all of them.
Perfect. Yeah, I am terrible at using like looking through all those menu items, but that's great. So there is a clear all outputs. That is awesome. Cool. Any other questions before I hand it over to Leah? All right. Leah, do you want to share your screen and walk through it?
Hey, so yeah, I'm gonna cover like sort of the basics of like how deep learning networks actually, like what is going on inside of them. And yeah, with the example of Google DeepDream, which were these, I think it came out in like 2015 and went a little viral with all of these like pretty psychedelic looking, yeah, images with lots of colors and dogs in them. But originally it came out of Google as a way to figure out what is actually going on inside of a deep learning network. So here, this is a diagram of what a convolutional neural network is. There are these things. You have an input image, which might be an image of a cat, but your overall network architecture is that you have these different layers. And what makes a neural network a deep neural network is if you have more than one layer, which makes it deep because there are many layers. And the way these convolutional layers are set up is you have a large layer in the front that kind of is the same resolution as your input image. And then with successive like later layers, they get smaller and smaller as sort of the information of your image is compressed down into more meaningful features. So in the beginning, what we actually find to like correspond to the different layers in the convolutional neural network is that the layers in the beginning tend to correspond to edges and pretty simple things in the image, like edges and textures. And then later on, like the later layers correspond to more meaningful high-level features, like this is an ear, or this is a paw, or this is like the face of a cat, or the face of a dog. And to sort of answer Peter's question about how, like, sort of how these things train and how it, like, what a pickle file is, or what happens in the actual GAN during the training process is while the GAN is training, it starts off with an input image of random noise. It's just like literally just like static looking stuff. And then through the training process, it passes that through. And then at the end, there's what's called like a loss, which is like a score of how good or bad it did. And then there's a step called backpropagation, where it just kind of like takes the information of like, okay, I did bad in these parts, and then sort of tweaks that noise image to sort of fit more like what a realistic image would look like. Yeah, and so that happens during the training process like many, many, many times. And that's what happens when you're like training a model for several days. If it goes through that forward pass and then a back prop to sort of make that noise image like more and more high fidelity to look more realistic in the GAN's output. Yeah, any questions so far? No? Okay. Yeah, so when convolutional neural networks like first came out or like became like really, really popular, I think in, I don't know, in like the 2010s or so, people were just like, wow, these things like are able to like classify things and detect things, but they didn't really know what was going on. They're just like, we just feed it a lot of data and it just kind of works. So a couple of years ago, there became a lot more interest in this field of machine learning called interpretability, which literally is just like, what is actually going on in here? What is the network seeing? How can we figure out, like, break open this network and make it less of a black box and figure out what is happening inside? So there's one technique for interpretability, which is just seeing like what's happening inside the network, called feature visualization. And what that means is essentially at every layer, we're just trying to figure out like what are the meaningful features that this layer is picking up on. So this layer in the beginning might be picking up on like edges, and then the next one might be picking up on textures, and then the later layers we can actually visualize that it might be picking up on like snouts of dogs or the ear of a cat. And so these pictures here are feature visualizations of these different layers. Like this first layer is called layer conv 2D0. This next one is layer mixed 3A, layer mixed 4A, layers mixed 5B and 4C, and 4D and 4E. And you can see like the deeper you go in this network, sort of the features that are visualized become more and more high level. Whereas in the beginning you have just these edges and textures, and then near the end you have like these flowers and things that look like eyes or buildings or, I don't know, a boy playing soccer. And yeah. So the way you actually do feature visualization is after a network is like fully trained and you're trying to figure out, okay, what is actually going on in this trained network, what you'll do is in the beginning, you'll input a random noise image like this, and then through successive iterations, like basically being like, okay, in this step, we're looking at this layer. How can we figure out how can we converge on an image that most activates this layer? So a particular layer, like the earlier layers, will activate on edges and textures. And so there's like this iterative process, kind of similar to the way it trains, where it's like, okay, I want to activate this layer more, and so I'm going to tweak these pixels in this particular way. And then, yeah, just through a lot more iterations, then you can finally converge on like something that a person can look at and see as meaningful. One pretty important thing when it comes to feature visualization is the first thing you want is like maximum activation of the neurons, which means that you're just saying like, I want the image that sort of like excites this layer the most. So for the early ones, those would be like things that look like these edge things. But another pretty important thing, which sort of I think made DeepDream really successful, or like made it very appealing to other people, was the fact that they imposed this constraint where the output images also had to be real looking, which means that like you get these things that look kind of like real dogs or like real beach balls, and you don't get things that look literally just like noise. If you don't impose this constraint of like that it needs to look real, then you end up with what are called adversarial examples, which here are some examples. So you might start off with random noise, and if you don't say like, okay, this has to look like a real dog or like a real photograph of something, then you'll just kind of end up with these images which to a human eye don't look like much, but when you pass them through a neural network, it'll be like, yes, this is definitely a boy playing soccer. And those are called adversarial examples because, yeah, it's kind of like tricking the neural network into thinking it sees something that isn't there at all. Yeah, and so that is literally just what DeepDream is. It's just feature visualization at the layer level. So there are these different layers of DeepDream, and yeah, the earlier layers correspond to like these patterns and textures, and the later layers correspond to these higher level like bookshelves or dog eyes or trees or billiard balls. Yeah, and there's this nice Colab notebook by Alex Morgenstev, who was an engineer on the DeepDream team. Yeah, I'll go through it. Okay, so this is a Colab notebook for DeepDream. There's this first, well, first let me make sure my runtime is correct. DQ, yeah. And so this first, let me run this first cell. This is downloading the pre-trained network. So this is just the trained network that we're trying to like deep dream on and see like what are the features that are in these various layers of this trained network.
One thing to note while this runs is that each of these models will have slightly different layer visualizations. So in this case, we're using what's called the Inception network, which is a pretty popular one from Google. You might also see people use what's called VGG, which is another model. So each model will have a different number of layers and a different sort of output of their visualizations.
Yeah. So, okay, this is downloaded. We have this Inception 5H.zip, which is the pre-trained model. Usually, a pre-trained model will be in a pickle file, but in this case, it's within the zip file. These cells are if we want to upload our own image to do DeepDream on. So we can go ahead and do that. Otherwise, it'll just be this default image of a dog. So let me upload. This is an image of some fish I found in a dumpster. That is uploaded. Cool. In this section, we're just literally just showing our image that we're starting off with. And this section is like all of the DeepDream code. It includes some functions to resize your image if your image is like too large. And yeah, this render DeepDream, which does the actual DeepDream algorithm. Cool. And yeah, this is the fun part where we run the cell, and it he's included these really nice sliders to that you can slide around and just alter these different parameters for DeepDream. This drop-down menu, you can choose which layer you're inspecting. So if we look at an earlier layer, mixed 3A, we'll probably get a lot of like more granular textures. So if we let this run, we have sort of these overall textures. Let me turn these off. Octave n is a parameter which sort of corresponds to how big, like on what scale is examining the image. So I just brought the octave n down, and now we can see like it's more granular, like these little boxes rather than these larger overall features. There's this strength slider. Strength sort of amplifies the effect of DeepDream. So if we crank it up, we'll get things that are higher contrast and more crazy looking, but generally turn out, yeah, a little more like granular and gritty, depending on like the effects that you want to create. Yeah. This notebook also includes a section for visualizing individual neurons. So within each layer of the network, each layer is composed of like a lot of different neurons. And so we can look back at this 3A layer, but within it, there are all of these different neurons, which are numbered. And yeah, this slider, I think, yeah, this slider is sort of just one slider for all the different layers, but different layers will have different numbers of neurons. And so you need to sort of just make sure that you're in the right, like you're choosing a channel number or a neuron number that is within the range of that layer. You might need to fiddle with it a little bit.
I'm going to add a link in the chat to a tool called Open Microscope, which allows you to sort of see, and this one is also linked directly to Inception. So you could see, this is sort of a visualization technique where I think the OpenAI team actually went through and found, like, did visualizations for every single individual neuron. So instead of doing the guesswork yourself, if you want to dig in and sort of see what they found, you could then hopefully like match that up to these channels. And so I think they call them units there. So you can match up the unit and the layer, and you would hopefully like save yourself some guesswork of what each one does. Sometimes it's just fun to like mess around and figure out different ones. But this one will help you give you a little bit more of a guide if you're interested.
Yeah, so this I guess neuron 87 of layer mixed 3A seems to correspond to these diagonal lines. If we go to a higher layer, like a 4C, and run this again, we'll probably get like higher level features. And let's see. Oh, and one important thing to note is that for this particular notebook, the way it's set up is that these sliders up here also correspond to this cell down here. So this bottom image, I'm like, oh, the strength is really, really high. And that is because up here, I cranked the strength really, really high. I'm gonna bring that down so the image doesn't look so grainy. Oh, that's pretty cool. Maybe I'll take a different feature. But yeah, you just kind of can fiddle around with this and play with different layers and check out different neurons and see what they produce. And this notebook also includes this pretty fun thing called zooming iteratively within DeepDream. Here, I think, this is Gene Kogan's work, and he's done like sort of played with these zooming things with DeepDream, where you just have an image and then you zoom into it and just kind of, you go into this weird world with lots of puppy sleds and things. And yeah, this notebook includes a section where you can specify a zooming factor, which is on each successive step, how much you zoom in, how many steps you do, and yeah, you can choose the same thing as before, like which layer and how many iterations and the strength. So we can just run this here. And so this will produce the output here, and then every single frame, it'll zoom us in a little more. Maybe I'll turn the screen back to but yeah, if you just let this run, you'll just keep going in, and yeah.
So are these images being like saved anywhere, or if you were wanting to save it to be able to stitch it together?
Yeah, there's
code.
Yeah, I think in this notebook there's not code to save it out, but it should be like, yeah, pretty straightforward to save it out. And yeah, I think Derrick and I are down to help you figure out how to like save these and make them into a video. Yeah, if you're trying to make a zooming video like Gene Kogan stuff, you probably want to decrease the zoom factor so that it's like not as choppy, and increase the zooming steps so it's more smooth overall.
Yeah, I'll provide some code so that basically you'll see in this at line 15 or whatever, it's generating the frame. So all you need to do is, I think we'll need to write a line of code to save that frame out. And I'll take a look at that and I'll share it this week.
Yeah, I think that is pretty much it for this notebook. I have, there's this page which sort of breaks down each of the individual layers of the inception model. And Like you can click through, you can make a 4A. And yeah, it includes a lot of information on this. Yeah, unit 1, unit 2. This might be the thing that you were talking about there. So they show all the different examples for each layer and each unit within that layer. Page is loading, so yeah. So yeah, it looks like this layer 4A unit 0. So if we went to layer 4A in the dropdown and then selected unit 0, we would get these things that look like arms or hands. This one is like these dotted flower radial things. Yeah, and things like that. Mike Taika and Dean Kogan have done a good amount of work making DeepDream art. And yeah, one last thing is there are a bunch of Colab notebooks from Distill, which they're the people that write these pretty great comprehensive articles on neural networks and sort of interpretability of them. And there's this whole set of different notebooks that you can use to visualize neural networks if you're interested in digging into them more. Yeah, and they're all related to visualizing different neural networks that you have trained or other people have trained. Yeah, any questions?
It's not specifically about DeepDream, but it's more about just pickle files in general. But are you gonna go over how to upload them to Google Colab? I've downloaded. I downloaded one from one of the links that was linked in the previous last week's slides, and it gave me a pickle file, and I didn't really know what to do with it.
We can go over that. I think there's two ways to do it. One is just to upload it straight to Colab, which is not my recommended way of doing it, because it just takes a while to upload these large files over your own computer network. But that's a great point. I will write up a little bit of detail on how to do that. What I really recommend would be to upload it to Google Drive, and then through Drive, either download it and move it to your Colab notebook, or using a thing, there's a technique called GDown, which is another like little pip library that if you get the share link of the URL in Google Drive, you can download it directly to Colab. That's usually what Leah and I do. And I'll write up a little bit of detail on how to do that. That's probably a really helpful thing to talk about. So yeah, but you could upload it if you just want to. You can upload it directly to Colab. All you have to do is drag it and drop it into that little file window in the left-hand panel. That will work. It'll just take a little bit of time to upload. And obviously, if you do that over and over and over again, you'll probably be very frustrated by how long you have to wait. But that's one technique, and that's like the most straightforward version. But I'll write up the GDown stuff as well then. And I should also add that like the feature visualization stuff, like we'll add a bunch of links to various materials for that. That could be like a whole class in and of itself. So it is definitely a big topic. What we hope that you could learn from that is like that helps you understand how DeepDream works. It also is a little bit of how style transfer works. So style transfer, if you like dig into some of the code there, you can pick a layer to pull each the style and the content layers from. So it actually ends up being that like there's a lot of techniques that use that sort of layer description as a way to access certain things. And similarly, like with StyleGAN, that the Peters video, the one that we looked at, is actually dealing with like manipulating the very first layer of a StyleGAN model and the very last layer. So there's lots of like, people are always doing some crazy stuff with these different layer techniques. So it's helpful to sort of understand what's going on there, so you can sort of maybe figure out what people are doing when they're manipulating different things. Cool. Why don't we take a 5-minute break? So let's come back at 25 after. And if you have more questions, I'm happy we can answer more as well. All right, see everybody in 5 minutes. All right, hello everybody. Any other questions about DeepDream? It's a pretty big topic, and I'm happy to answer questions but also want to make sure we get to the other materials. So maybe, yeah, maybe if there's one or two other questions I can answer right now about it.
I guess I'm just curious, like, I mean, I understand in theory, like we're talking about neurons, but like from a practical standpoint, like what are we talking about?
Yeah, great question. So I mean, I think, you know, one is obviously how DeepDream works. Like you could obviously like figure out like choosing an individual neuron, and you can apply that to DeepDream to create new sort of images out of it. In other practical terms, neurons aren't really used as much anywhere else. Layers are used in things like style transfer, and layers are manipulated in things like StyleGAN and other places. So, you know, again, it's a fairly deep topic, and I would say that for many of us, we're not going to go in and individually alter layers, but I think it's just helpful to sort of understand, because that can, especially the idea of like early layers versus late layers, can help you sort of understand, like, am I manipulating like really early stuff in terms of like basic geometry, or am I manipulating the end layers in the sense of like really high level detail? And I think we'll go over one of the notebooks that is called, why am I blanking on the name of it right now? Oh, network bending. So we'll go over network bending in week 4. And network bending does the same thing, but to a StyleGAN model. And it's important to know that like every model has their own like sequence of layers. So in the case of Inception, I think Inception is like, there's many layers inside of it, but it only sees like 6 or 8 as like the main layers. StyleGAN has 16 layers. So when we look at network bending, we'll be talking about which layer am I manipulating, and how does that affect the individual output. So it's more conceptual, but like it shows up in lots of other places. And like understanding that is really key to understanding what's going on with a lot of these models. Cool. We'll link to some more resources for some of this stuff as well. So hopefully if you really want to get into it, we can answer some questions there. So I want to finish up class with 2 things. The first is going over, oops, lost my screen here. 1 second. So I'm just going to start with some inspiration. I know that like lots of folks mentioned in the survey that they sort of want to see what other people were making, maybe get some ideas for things that they could make. So all the work here that I'm going to show are things you could do pretty easily with notebooks that already exist. So while I have some other videos on other inspirational materials, I'm focusing sort of mostly on things that I know people could do within notebooks that already exist. So you'll often see you know, people like Mario Klingemann, who's like a very famous sort of like StyleGAN artist, will do stuff that like I still have no idea what he's doing. I could show you that, and then you would be frustrated that you can't do that yourself, because there are no notebooks that exist for this. So most of this stuff is within the realm of what I think anyone taking this class could play with within notebooks and make interesting things. So Mike Taika came up when we were talking about DeepDream. He's mostly known for working in DeepDream, but he also does a lot of stuff with style transfer. And I don't, looks like I'd lost the link to his, he wrote like a long thing about messing with style transfer and doing various things. So this is style transfer work, but he's sort of manipulating, I believe, both the images as well as some of the layers. So like, again, there's ways to play with this stuff. And, you know, the thing that I find with style transfer is, and this is true of DeepDream too, is when they came out around 2015, they had like this like big moment where everyone played with them. And then people like immediately were like, okay, this is old, I've seen it all before, I don't want to come back to it. But particularly with style transfer, I think there's so much to do within style transfer that is still ripe for exploration. So this is actually, I think I've got a couple style transfer sort of things to experiment with here, or show you to work with. But I think it's like, this is a valuable area, and it's pretty simple to do in the sense that you don't need to train anything. So training will generally take days or weeks of your time. Style transfer doesn't really require training. It's sort of what we call pre-trained, or like using, again, this sort of VGG or Inception networks to do some things. So in that case, it's like fairly straightforward, and you just have to play with it and experiment a lot. This is Mike Taika's work. This is some very, very early work that I did. This is actually using an app called DeepArt, where you can just send it an image and a content image, and it sort of blends them together. So I also know lots of people are interested in typography here. So I did some really interesting, or like early examples of sort of creating typography and textures and those sort of things. So again, this is just pretty straightforward style transfer. When I taught this class, or like when I taught a class similar to this a couple months ago, Jess, who is Skullface on Twitter, did this example of where she applied style transfer to shoes. And she also did a lot of cleanup work. So I think what's important here is that a lot of times what you'll see are not just the like final output of things, right? So here is the final output from, I believe, Runway. And then she took it into Photoshop and cleaned them up. So again, don't feel like, you know, you have to be like true to the medium or whatever and just stick with the results. You can go in and also like edit things afterward. And I think like you probably should as an artist, like feel like you're also putting your touch or also like cleaning things up. So this is just like, I love this example because it shows that you can generate materials, but then there's still design work and still artistic work to be done after the fact. This is an artist by the name of Lulu, XIX or XIXX. And this is an example of style transfer video. Now I will admit style transfer video is hard to achieve on Colab. You could do it with a very, very short video. Part of the reason is that you have to do some pre-processing of your video, and that can take a long amount of time. So you could probably maybe do it in a couple steps. But this is sort of, I mean, this is really fun and really interesting experiments with just, you know, I believe the artist is Naj Barker or something. And Lulu took that work and sort of applied it then to these videos. And I don't even know what the content is underneath here, whether it's like zooming through a park or something, but it's pretty interesting to see. So again, I think style transfer has this like very like wide range of things you could do. And not a lot of people are exploring it as much these days, which is kind of a bummer. Next, we're gonna look at some next stream prediction stuff. So next stream prediction, I've got a couple of videos on exactly what this process is if you're interested. Next stream prediction essentially tries to predict what a video sequence is, frame by frame. So this is Mario Klingemann's work. Mario is often the innovator or the beginner of a lot of these techniques, and then people sort of take them and do their own thing with them. So this is a machine learning model trying to figure out how to generate fireworks. And when we talk about generate, it's actually more like trying to figure out the frame from a previous frame. So what you do is you train this model and then you seed it with a single realistic frame, and then from there it tries to learn everything else. So this is an example of his work. I really like this stuff because you can see what it's supposed to be, but it's never quite accurate. And therefore it always generates some really, really interesting material. So you'll often find that they generate these sort of like edgy looking things, and that's because of this convolution network. It happens quite frequently that you get these like sort of reaction diffusion style textures.
Do you know if this was trained on a video or like an image sequence or a bunch of different firework images?
It was probably trained on a single video sequence. So the process for this, and there is a notebook for this up, and I just recorded a video on starting training, and I'm going to do one this week on generating the images once you're finished training it. Basically what you do is you upload a video. The video, you then run a command that splits it all into individual frames, and then you train on those frames. This is Jonathan Fly, who did similar work. But the thing that's important to know here is that your input video, which is like true of anything, your inputs matter a lot with deep neural networks. Your input here it determines your output. So, you know, here it was a roller coaster, which you can obviously imagine sort of zooming in and out on, but like, look how crazy this output is. You know, you can kind of see where it's coming from, but like it still is just really, really weird. And it produces these really amazing, like glitchy sort of video artifacts. I think, Dan, did you work with next stream prediction previously this week?
Yeah, I got some really glitchy results. I tried another video today, and yeah, it really depended on, I think it was similar to like stuff you had talked about recently, where like how much of the frame is static as well, because I got some really subtle results and then some like really bonkers results.
Yeah.
I did find like the whole concept of like the epochs and stuff to be a little, it took me a while to kind of understand what was going on there.
Yeah. Yeah, and I'm planning to record a video that explains a little bit more about that and how to actually generate different types of video based on that. But essentially epochs, which is what Dan's talking about, is for how long it trains is like how far along in the training process it is. So if you pick epoch 1, it's going to be very early in your training process and it'll be very, very noisy and very messy. The further along you get, the idea is that the more it should replicate the video you've seen. But that doesn't always work out. And like with all these networks, they're never perfect. So yeah, so there's lots of different things to play with here. There's also like what we call seed or what image you start with matters a lot in sort of the output as well. So it's a pretty like, again, this is an area where you could spend a ton of time and like spend a month just exploring different ways of using next range prediction. But it's pretty interesting and you get some pretty interesting results. This week has been like me going deep on next range prediction. So I've recorded a bunch of different like examples that are up on my Instagram or Twitter if you are interested. Cool, next we're gonna cover some examples of things like what we call image-to-image translation. You might hear this referred to as CycleGAN or Munit or Pix-to-Pix. But the idea here is that the inputs for this are actually two groups of images. So, you know, it could be, this is horses to zebras for those of you who are familiar with my favorite video. It could be a group of horses and a group of zebras, and you train on those together, and the model tries to figure out how to translate between them. Helena Sarin is sort of the, I would say the innovator in this area, in that she is just wildly prolific and generates a ton of materials and always gets interesting results. And I have no idea most of the time what she's training this stuff on. Like I sort of have a theory that like this one on the left here is trained obviously on flowers, but I don't know what the other one is. And I think it's almost like oil patterns or some sort of like, you know, water droplets or something, so that it's basically training how to like fix a flower into that shape. So really interesting stuff. I definitely recommend checking out her work. She is very prolific and always adding new images to her Twitter feed. This is some of my work, which is related to this. So this is all CycleGAN. And this is moving birds and so this is a list of birds and, or sorry, a folder of birds and a folder of flowers. And what's helpful to know about these particular models is that you can go from A to B. So like from birds to flowers, or you can go from flowers to birds. So in the top section here, you've got birds who have been sort of turned into flowers, right? You see like they've got flowery structures behind them. And then below you've got flowers that have been turned into birds. So you'll see like the leaves have turned into like bird feathers, or the flowers themselves have sort of turned into bird shapes. So CycleGAN produces some really weird stuff, but it's a lot of fun to play with. And I would also say like, you know, we're not gonna cover too much on data sets in this class, but if you are interested in sort of like what's the easiest thing to train on, next range prediction is very easy to train on because all you need to do is find a video. CycleGAN is sort of also pretty easy in that all you need to do is find 2 folders, and they can be pretty small. It could be, you know, 100 zebras, 100 horses, and it'll still do like a decent amount of work. So this one's pretty fun to play with. Training usually on Colab takes a day or 2, depending on how long you train it for. So just be aware of that. Go ahead.
Yep. Something.
Yeah, go for it.
So when you're, I've just been wondering for like a lot of the models, with the prior example, were you feeding it a specific image, or is it like the case where you train the model on like 100 images of birds and 100 images of flowers, and then it's like generating its own?
Yep,
Or
exactly.
like
So
you give it a specific one and then it actually translates.
So it's the latter. The latter is basically like you feed it a bunch of images and it tries to figure out how would I generally translate between all of these birds to all of these flowers.
Okay, and then with the like the zebra to horses video, in that instance, because it's not like the smoothest thing, but it's pretty smooth. So are they like the video, the DeepDream video or the style transfer video you showed earlier? It's like super smooth, and you don't have all those like jittery artifacts of just doing it like image by image, and it seems to know like a little bit of like the motion vectors ahead of time. So with that one, do you know, are they just going image by image, or did they process the video little bit ahead of time.
The horses to zebras video, I assume they just fed it frames, and that's why it's a little jittery. You know, it's not perfect. It depends a lot on the type of model. So I've done some other examples with CycleGAN where I have fed it like just frames of a video, and it's been very flickery. Motion consistency is kind of a hard thing. That's why that the Lulu's video that feels really smooth. It's because they're doing a thing called optical flow, which is tracking a lot of that. So that's why that one is so smooth, and why other ones you'll see might be a little bit flickery. And I don't even know if you can use optical flow with CycleGAN because of the way CycleGAN doesn't really have a concept of masking, which is what they build into some of the style transfer videos. So yeah, it's one of those things where like, I'm sure someone could probably create it. It feels like it might be a little bit outside of my wheelhouse, but yeah, motion consistency is definitely one of the harder issues with a lot of this stuff.
For some of these models, or like any model out there really, but do you ever need a larger sample size like in Runway where it's in the thousands or like more than that? Because I feel like a lot of the models we've seen are like 100 or like for Syngas it's 1, right?
Yeah.
So are they usually more on the smaller group or like a number compared to Runway?
They're usually on the higher side, actually. I would say most models require thousands of images or more. And usually kind of what I highlight in this class is, because I know that's hard for a lot of people to come up with, are some of the smaller ones. And there's reasons for why you need bigger representations versus smaller representations. So for example, the reason that CycleGAN works with a smallish size of images is you're not trying to learn an image from scratch like StyleGAN, right? So StyleGAN is trying to learn all these images from nothing, basically. So you need a ton of data to make that happen. What CycleGAN is trying to learn is how to translate from one image to another. So really all it needs, you could really get away with 2 images. It would overfit, and it would eventually just like memorize how to go from one to the other. But you know, it's not starting from scratch. It's starting from like an image, and it's learning how to translate it. So, and then SynGAN, because it's, you know, the output is essentially like the same image, just noisier or sort of manipulated a little bit. It doesn't require as much. So like, and this is again, like different models are trying to solve for different use cases. So SynGAN is kind of trying to solve for like the example of I have one image and I want to manipulate it, or like the idea of, you know, texture synthesis, which we haven't really talked about in this class, but like texture synthesis is essentially like, give me one texture and allow me to manipulate in many ways to like gaming is big on texture synthesis, that sort of thing. Yeah, so each of these is sort of generating their own, they're trying to solve for different problems, essentially. And that requires different data sets.
This was just another question I've had for a while. With StyleGAN in particular, can you feed it a specific image though?
Not really. There's a thing called, oh my God, I'm so brain dead today. Leah, help me out here. What's the thing where you stick a video in, or stick an image in, and you find the closest representation of it?
Oh, projection.
Projection, thank you. Yeah, wow. Yeah, so there's a thing like projection, which is essentially you can put an image into a StyleGAN model, and it tries to find the closest representation of it. But that's not the same as being able to say like, hey, I want to start with this image and do this. Yeah, so it's a little different. Actually, this model, Munit, does allow for what they call guided translation, which means once you've trained the model, you can feed it a style image, and it will guide it based on the style image you give it. So it's almost like style transfer. Munit is nice. So so basically CycleGAN, this is getting very terminology heavy, but CycleGAN is deterministic, meaning if you feed it the same image, every time you feed it the same image, you'll have the same output. Whereas Munit, and this is an example of like sort of different outputs. This is the same content image fed into the model, and I can set a seed value to change the output. Now you might look at this and just say, oh, well, it's just changing color, right? But it's actually not. If you look at very like, you know, in detailed areas, like if you look here and then you look here, you'll see the textures are different. So this is an example of, you know, non-deterministic or what they call multimodal. Again, they always generate like the craziest terms for these things. This is a multimodal output. So it's helpful. Like I tend to use Munit a lot more nowadays because of that, the fact that it can do this multimodal work. You sort of get more bang for your buck when you train a model, because training takes time. So in the case of CycleGAN, like you don't really want to just get one output out of every image you input. It's nice, or like, you know, Helena and I talk about this a lot, and Helena has said that she prefers CycleGAN just because she likes the way the network works, or like she likes the outputs better. Whereas Munit does have some issues where like there's some noisy patches or things. So again, a lot of people who like play with this stuff all day will have like lots of personal opinions on various things. Okay, lastly, I know we're running a little short on time here. This is a bunch of StyleGAN work. I have many videos on StyleGAN inspiration materials that I'll link to. So if you are interested more in StyleGAN, we'll definitely cover a lot more in the last week of class for this. Kisha Yuma is just one of my favorite StyleGAN people. This is a really, like, what's cool here is this is probably a video that he used individual frames from, right? So it's just someone doing like this with their hands, and then he recorded it and he like ran it through StyleGAN, and then he ran it back, and you get this like funky, like almost human looking hand, but it's doing weird stuff.
When you say you fed it the video, you like he trained it on the video of the hand, like you.
Yeah, I mean, you never train it on a video. You basically break a video into individual frames, and you train on the frames. But yes, I would assume that's how he made this one. Elena is a student of mine. She was previously in a StyleGAN class with us, and she loves birds. She is like a big birder. So she found all of the same, these are all the same bird type. So she found thousands of images of the exact same bird and ran that through StyleGAN. What I love about this is, you know, she talks about how this is essentially like the same, this like highlights a trope of bird imagery, which is birds sitting on branches and like always centered. So like, it's great because the bird sort of stays the same, but the background does this crazy stuff. And this is a case of where image alignment matters a lot in terms of your data set. So if she were to move the bird up to the right, down to the left, you know, sort of move the bird around, it would get very noisy. But because most birding photography is bird-centered on a branch, it all sort of aligns perfectly, and you get this really great example of like that sort of background craziness. This is an example of projection. This person is great on Twitter. I actually will bring them up again in a minute. But this is an example of trying to find Mario inside of the FFHQ StyleGAN model. This is pretty disgusting looking, but like it's fun, right? And this sort of shows that, like, again, sort of similar to what I was talking about with Peter's video that he posted in a Slack channel, like there's stuff deep in these networks that we don't really know about. So again, this also ties to sort of the Leah's discussion of what these layers have in them. You'll hear a lot of people refer to deep learning as a black box, which means we don't know what's going on inside of them. And that's sort of what this interpretability study is trying to do, is trying to find out what's actually in them. And projection is another case of where, like, what's actually in this model? Like, what does it know about faces? Because clearly we trained it on a bunch of human photographic faces, but yet it can still find this thing inside of this model. That seems really weird, and it is. But this is sort of, again, like things you can kind of play with, right? And it's like clearly not Mario, it's clearly not perfect, but it like is really close. So it's pretty amazing, actually. I don't know that we'll look at GAN space in particular in week 4, but GAN space is, again, I think this idea of what we call feature visualization, which is a lot of people are interested in being able to almost turn a GAN into like Photoshop, but like a really smart version of Photoshop, right? So can I take someone's face and make them smile? Can I take someone's face and like change their eye color? Can I change their hair length? You know, that sort of like is the forefront of what a lot of people are trying to do with GANs these days. GAN space is one of many different ways of being able to do this. And you'll see here again, they're talking about these things called components, which is almost a way of thinking about layers. So there is like really fine-tuning things. There are ways to change major shape structures. All this stuff ends up tying together because it's all sort of trying to manipulate the same things, right? So how do we do fine-tuning? How do we do like large-scale shape changes, those sort of things? So, you know, GAN space, Lee and I did a class on StyleGAN 2 earlier this year, and we did a whole video on GAN space. So if people are interested, I can link to that. It's a little complicated in that you have to do a bunch of different things to make it happen. So I probably will skip it for week 4, but if you want to play with it, we have a demo video and a notebook for it. So that just covered like a very brief introduction of sort of different materials. And it focused on maybe 3 or 4 things, which is style transfer, next frame prediction, cycle GAN, and style GAN 2 in particular. Those 4 tend to be the things that I most likely teach on, just because there's a lot of material already out there to learn from. There's a lot of good examples. But I think, you know, to other points, like SynGAN is a model that you can play with. There's a lot of other new models coming out. It's just these tend to be the big 4 buckets of categories that people play with things in. So, you know, just some examples of things you might be interested in. I tend to find that like you start with an idea and you play with it and you sort of learn like, oh, I need to change the input a lot to make this happen. I think it's something that Peter and I talked about yesterday. And I know I've talked about this with Chris too, is that if you come in from like the generative art world, you're used to writing a lot of code to like make things happen, right? In neural networks and machine learning, I tend to write very little code. What I tend to do a lot of is play with my inputs. So in a lot of cases, it's what does my data set look like? Or how do I tweak an input image to better get an output? So it's a very different sort of experience to generative art. If you're used to writing processing or open frameworks, you have a lot more control over like doing the exact manipulation. Whereas here, you're kind of almost like throwing stuff into the void, seeing what comes back, and then trying to figure out what happens, and then changing your input, trying it again. And like you're learning by almost, it's not osmosis, but it's like learning by like trying and failing. So it's a very different process, but it's one that I find really fascinating and really interesting. And people are learning new things every day about these models and finding like there are people who do write a lot of this code and are finding new ways to do it. You know, the challenge here is that if you want to write code to make your own neural network model, one, you have to learn TensorFlow or PyTorch, which is a very like high lift, but also you tend to have to do a lot of experimentation just to get something to work right. There's lots of issues you can run into with these models. So a lot of people will tend to, you know, they work at NVIDIA or they work at Adobe and they have access to thousands upon thousands of GPUs. So they can run many different examples of things to sort of learn from. So we're not yet at a place where I feel like everyone could make their own model and like tweak things the way they want to and like very quickly find a solution that works for them. We're not yet there, but I think we're getting closer every day. But I would say like to start with, just start by playing with your inputs and outputs. And a lot of that is sort of going to help you sort of find out how to work with things. Any other questions about any inspiration materials, or is there a model you've seen that you want more examples from? I'm happy to try to find some links for you. Cool, I think we've got 5 minutes left, so I'll quickly run through this. The good thing is that I recorded a video to cover how to do this work. So I'd recommend watching the video, and then if you have more questions, or basically the real thing is like if you have an example of a notebook that you want to convert, it might be best just to like show up to next week's open working session, and like Leah and I could walk you through how to do it. This is kind of a trial and error process, but I've learned a couple things that I'll go through as we walk through this. So this is basically like, let's say you find a model on GitHub and you want to figure out how to put it in a notebook to play with. It's not really conversion. It's more just like, how do you like take the code that you see and put it in a notebook? So the first thing you might be asking is just like, how do I find new papers or new models to play with? The world of machine learning is kind of interesting in that it's very heavily tied to data science and research. So quite often, things will be released as papers, meaning there will be literally a PDF. It will be on a site called Archive, and there will be a paper where someone explains what they did. There will be a ton of math in it, and you will look at it and you'll be like, what the hell is this? But then someone will release a demo video of what they did, and you'll be like, that's really cool. I want to figure out how to do that. A lot of times, you will start with the paper and sort of be like, how did this work? Where can I find how to work with this? So there are many places to find papers. These happen to be my favorites because many of them are, for a couple of reasons, like many of them are, so AK, which is the person I mentioned before that did that projection model, their Twitter stream is awesome. Like I swear there's like 5 models every day that I want to play with, linked to from their Twitter. So I definitely recommend checking that out. Henry AI Labs is, I think he's a data scientist and he will like walk through papers and sort of how they work. So this is a little bit easier than trying to read all the math. I will say that sometimes he still doesn't like make it very clear how a thing works, but it's a nice way to just sort of watch some videos. Archive Sanity is a website devoted to like, basically the archive site is terrible. So this is a way to easily parse all of the archive papers. There's like a trending tab. There's a bunch of other tabs. There's a bunch of options here. If you get really deep into reading papers, this is the place to go. There is also a papers channel on Slack. So I will tend to, I and a couple other people will tend to add papers there. And sometimes we decide like, okay, let's turn this one into a notebook. There is code for this, or just we'll talk about how these work. The one I want to quickly focus on is just called Papers with Code. It's now owned by Facebook. So take with that what you will. But what I like with Papers with Code is these are guaranteed or almost always guaranteed to be a paper plus a GitHub repo. So the #1 problem with most papers is that people never release the code for them. So you will often find a really cool paper and then you will never find that they release the code. And that means you can't really do anything with it unless you're like a really, really smart machine learning engineer and you know how to convert math into code. But in general, like this is a cool site to go to because there are both papers and code next to each other. The other thing that's nice about it is they do a thing, if you look at Browse State of the Art, you can come in here and look for a category of things and perhaps find what they call state of the art, which would be the best version of that topic. So in the case of, if you want to do pose estimation, which is tracking body movement, you can click here and they will sort of tell you up here, like what are the, this is the paper title and here are the networks. Now what is on the left-hand side here, and this is like, there are data sets and they are usually scored. So these are the data sets that people are testing on. And then there's a ranking of how each one is doing. So if you click on this graph, you'll see here that each of these is being scored. So each of these is a paper. So this is the NIPS 14 by Chen and Yule. So it has this score, which is apparently a low score. And then as you get higher up, you will see that each of these has a slightly different scoring method. So, the difference between soft gated skip connections and residual hourglass is very minor. But this is a way for you to sort of know, like, this is the best scored one. Scoring is like kind of a complicated and fuzzy topic. So I wouldn't necessarily like buy into it as like, this is the perfect model to use. But you'll also see here that each of these, where there is code, there's a link to the GitHub page. And if you click on this, you will go to a GitHub page. And hopefully, this one looks pretty good. Hopefully these are well documented. The challenge here is that a lot of these are sometimes not, or sometimes missing parts, and you will run into a lot of issues. But I always start with papers with code just as a place to start looking and see what's available. Okay, so once you've found a paper or a model, one thing that's, again, really important to remember is not all papers actually include links to code. So just be aware of that. The steps to go from here are, you usually have to find this code repo. It's almost always on GitHub. Very rarely it's on a place called GitLab, but GitHub is almost always it. You want to create a new Colab notebook. So just go to Colab and click new notebook. And then the steps from here are basically like in code cells. You're going to clone in the repo into Colab. So that's usually this command. You use, exclamation point git clone and then the URL of the GitHub. Next, you'll need to install the dependencies. And this is a little bit of a complicated topic because Colab comes pre-installed with a ton of dependencies. So quite often you don't need to install any dependencies. But if you do, they're almost always using pip. So you do, again, exclamation point pip install and then the name of dependency. Leah's done a good example of this, I think, in one of her videos where she found that, like, I think G event was missing. So she knew to install it using this. And then in a lot of cases, we go back to this notebook here, or we go back to this code sample here. There's usually some sort of training and testing command. So this is a example of quick start. You pass in this main, this is what's called a torch model, which means I don't recommend using this because torch is out of date and no longer supported. That's another tricky little thing to know. But basically, if this were PyTorch, it would be something like main.py and then a bunch of commands. And you have to sort of like decipher what each of these arguments means. Usually that means reading the paper or seeing examples of what they've done. So this is like the very, very high level overview of how to convert these notebooks. I've got a video here where I actually walk through converting one of these and talk through some of the challenges. So if you're interested in doing this, I recommend watching this video first. I also recommend setting up time with Leah and I just to sort of like walk through converting one of these, because I think it's like, it's a little bit easier to understand when like you have someone who's done it before to walk you through things. So there was a chat question. Oh, okay. Sadie said to leave early. Cool. Cool. So that pretty much covers everything we wanted to in class. So I think your homework assignments for this week are: one, try converting a model. So maybe play with papers with code and see if you can like find a model. And even if you can just find a model, like that might be the first step. So try to find a model in GitHub that sounds interesting. And then maybe reach out to Leah and I, or just maybe post in Slack that, hey, you're going to try to convert this one. And one of us can also take a look at it and maybe let you know if there's going to be any red flags. So the first thing to know is that if you see a thing called torch, or if you see files called .lua files, avoid at all costs. Like you just can't do it because torch has been, people don't use torch anymore, or they shouldn't at least. So PyTorch and TensorFlow, if you see those two words, those are good things you can do. You can work with those in Colab for sure. So try converting a model. For some of you that may seem like pretty straightforward. For others of you that may be a bit of a challenge. But again, Leah and I are here to support you. And then I would say, again, just like keep playing with models in Colab. So maybe now that you've seen some examples and some inspiration, you want to give a shot at some of these different notebooks you've seen. If you are interested in starting, so next week we're going to focus a little bit on training, but we won't cover too much training. If you are interested in something like training your own cyclogram model or something, let Leah or I know, because there's probably already videos on our YouTube page that we can link you to sort of walk you through those steps. And if there aren't, I'm happy to record a video to sort of help you with those things. So yeah, so with that, are there any other questions? I know Nauko wanted to maybe look at how to upload a pickle file, so I will do that after we're done, if there's any other questions.
Could you also post that zip code
Yes.
through the channel, please? Thank you, because I lost it.
Yeah, actually, let me see if that zip code is in. So one thing I linked to in the class notes is this snippets notebook. And there's also a video showing how to install this into Colab. So yeah, so the zip thing is here. So I recommend following that video so you can install all of these snippets into Colab. That way you always have access to these, and they'll show up over here on the sidebar. And I've done a thing where I've underscored all of them, so they always show up at the top. So if you install this following that setup, you'll always have this snippets, and the snippets is the second tab here. If you click on this, you'll always have this code. And the way the zip thing works is you pass in the zip command. -R means recursive, which means just look at every file in this folder. You'll then give the zip a name. So you want to name your zip so that you understand what you're downloading, and then you'll give it a path to the folder. And I'll also include a GDown example so people can have that.
Just to throw something else on there, something I found useful when I was playing around with the paths yesterday, because I kept getting lost about like, it's like, what is the path for this directory? Is if you pull open the file thing on the left, it's either right click on it or do the dots or something on the folder, one of those things. You can do copy path to this folder.
Yep, exactly. Yeah, that's a great point. So this is something that Nauko and I went through, which is if you either control click on a file name or you click this little ellipses menu, you will get a copy path. And yes, this is really, really important. Copying the path out of this is way easier than trying to remember it yourself. So if you copy this path and then you paste it into a code cell, you will get the path to this file. And that is hands down like one of the #1 things I use. I'll leave a note in here about how to do that, but there's no code to do it. You just sort of have to like remember to click the GUI. But yes, agreed. That's a very helpful thing to add. Other questions?
I ran into an issue. I don't know if it's an issue, but it was a warning error, and it said connected to GPU runtime but not utilizing GPU?
Yeah, so that happens. Basically, Colab would prefer you not use a GPU unless you need to. So when you switch your runtime to GPU, if you're doing certain things in your notebook, but you haven't run like a training command, or you haven't run a thing to actually access the GPU, it will yell at you because they don't want you using it unless you really need to, because they're like expensive to them. That's fine. I always get that warning message, but it basically just wants to remind you like, hey, make sure you're using the GPU. Otherwise, you're kind of wasting our time. Colab says that like they will eventually like not ban you, but they will like reduce the amount of time that you get to use a GPU notebook if you don't utilize the GPU frequently. I think it's kind of annoying that they yell at you while you're like setting stuff up. But yeah, it's just a warning. They're not going to like ban you or anything from using Colab, but you know, just be aware that like if you're spending lots of hours using like just writing code directly in Colab but not accessing the GPU, they will get mad at you in some way or another. Okay, if there's no more questions, really quickly, let me sort of walk you through how to get a pickle file into Colab. So let me just open, let's find an interesting notebook here. I think we can use, we'll look at this notebook a lot in the last week of class. This will be a StyleGAN notebook on how to manipulate and create StyleGAN images. So in this case, let's just connect here. So this just installs the repo. One thing to know about TensorFlow is that TensorFlow has two different versions. There's TensorFlow 1 and there's TensorFlow 2. And pretty much everything needs TensorFlow 1, but Colab defaults to TensorFlow 2. TensorFlow is a Google thing, so they're like trying to push that. So this is a snippet that I added, which is that if you get errors that you can't run a certain thing, it's often because of this. So I tend to add this to most of my TensorFlow repos just to make sure that it works. So let's just install the code we need for this. I'm going to run this and skip this for now. So the next thing we need to do for StyleGAN, you need a pickle file. That is usually called your network, your model file or whatever it is. So there's a couple places you can get these from. The one that I tend to look at for or tell folks about is Justin Pinkney repositories. So Justin has a really nice page of awesome pre-trained StyleGAN 2 models. So if you click on this link, you'll see there are a number of models, including one that I've made, including a number of other ones that people in the StyleGAN community have produced. So there are many, many options here. And you may be able to find other ones if you're interested, but this is the one that we can work with. So how big is cats? 256, all right, I don't know if 256 is actually gonna work for us. So this is the most common one. You'll see the faces, this one, FFHQ config F. This is the one that most people are building off of or whatever, but there are many in here. So I'm just gonna grab the one that I have given to him, which is the FreeAGAN abstract art model. So the download link, if you click this link, so two things to know here is that this is a way to get, for anything that's on Google, which is where most people host their files, what you're really looking for is the ID. So what I wanna do is just copy the ID from here. And then I'm gonna bring this in, and here is a thing called GDown. So GDown is basically a way, it just downloads files directly from Google Drive. So what you do is you type in !GDown and then ID, and then you just, this is passing in the ID of your file. So if I paste this in, and let me just rename this file. So what this is saying is, take this Google Drive ID and download the file and save it as this. So dash uppercase O says what should the output name be. So this is gonna save this file. I don't care what the name is on Google Drive. It's gonna save the file into content, which is your main folder here. And then it's gonna name it freeagan.pickle. So if I run this, this is going to download. Now, the nice thing about this is the reason this is so fast is because you're on a Google server and a Google server on Colab. So the latency is like really, really fast. So this, you know, is a 380 megabyte file. If I were to try to upload this to Colab directly, it's going to take like 10 or 15 minutes. That took, what, less than 30 seconds. And if I refresh here, I've now got this file. So this is one way to work with it. This is helpful if you have pre-trained models. Now, if you have your own model, what I recommend you do is you upload it to Google Drive it yourself. So I have a ton of models myself up here. Switch to my work account. So you'll see I have quite a number of files in my Google Drive from doing a lot of work here. This weekend's project is to clean this out. So I have a folder of StyleGAN2 transfer models. And also if people are interested, I'm happy to like give you guys some of these files if you want them. I don't share these with other people, so just be aware of that. This is one of the bonuses of you being a part of this class. So if you do see one that you work with me, I'm happy to share it. So let's take this one again. So this is another free GAN model. So in this case, what you need to do is you'll right click on this file. You'll hit get shareable link. Often this will default to restricted. So the first thing you need to do is you need to turn this to anyone with a link. And that just allows people, like basically any server, to be able to access this file. Then you're gonna hit copy link, and then you're gonna come back over to your notebook. And when you paste the link in, you get the whole URL. Now the problem is you don't want the whole URL, you just want the ID, which is anything after the slash command, and then you wanna remove the slash view. So this is just the ID. It often starts with a 1. It's like a long string of letters and numbers and characters. So here, let's do StyleGAN iDrive. So here again, I'm gonna hit shift return, and I'll download this again. So again, the reason that you wanna do this off of Google is because it's on 2 very, very fast servers, probably in the same server farm somewhere. So you get a really, really fast transfer time. If I were to drag this file up here, it would take 15 minutes, and Colab will yell at you while you're like not running anything. Nako, is that helpful? Cool.
Yes, thank you.
Okay, awesome. Yeah, so the technique, and this is why I recommend like having a Google Drive account, and you know, if you're gonna do a lot of training with this, make sure you upgrade to a larger storage size. I think the 2 terabyte costs something like $100 a year, or maybe $120 a year. If you do this a lot, it is very, very worth that money. So I definitely recommend upgrading if you can and if you want to. Cool, so that just covers getting pickles in. So one thing you can do is you can download a pickle from the internet that isn't on a drive URL, add it to your drive, and then import it in this way.
And so you can just use a regular folder. Yeah, just regular Google Drive folder.
Yeah, a regular Google Drive folder. Now, it's important to know that you can't use GDown on folders. So for example, if I try to grab the folder of this and copy the link of this folder and try to paste that in, I believe you'll get an error message. It can only work with files, which is why you tend to see us zip things a lot. So you tend to want to zip up a folder. And then actually, let me just see if I remove this. So if you remove this, it should just, it'll just default to whatever the other name is. I think this will throw an error. Yeah, so you can't ever copy over folders. So that's why you'll see us zip something up, upload it, use GDown to download the zip, and then you can run an unzip command to unzip that file. And that leads me to believe that I need to write an unzip command in here as well in my snippets. So I've got a couple of things that I'll add to the snippets file in order to help people get access to these things. So unzip. So I'll have to look up what that command is because I can never remember it. Like the truth is I never remember what any of these commands are, and I just Google them once and then I save them to a snippets file and then I have access to them whenever. You know, I know a lot of folks are like, I don't know Python. It's like, I don't really know Python that well either. I Google things, I try it, and then if it works, I turn it into a snippet. So like, for example, if you do want to play videos in Colab, there actually is a way to do this. A former student of mine, Caitlin, figured out this technique. So you can use this snippet, define this in one of your early code cells and run it, and then you can play video directly inside of Colab. It basically converts it into an HTML5 video element, and then it is able to play it. But like, I don't know what, I mean, I can guess what most of this Python stuff means, but she probably Googled it or figured out how to make it work, and then we just turn it into a snippet. Cool. So we're a little over time now. So if anyone has other questions, what I recommend doing is posting them in Slack, and Leah and I or other folks can answer them as needed. Sound good? Cool. All right. So we'll see everyone next week. Just a reminder, if you can make it and you want to talk with Leah and I, the co-working sessions are Saturday afternoons, at least on my time. I think they're Saturdays like at noon for Leah. But yeah, please feel free to jump in those. We are happy to talk. They're pretty much free for all. Like, people just sort of show up, and like the first person who shows up gets to talk to me first, and just sort of form a queue. One thing I will note is that we'll announce them every time, like the day before. If you are going to attend, please, like, or you think you're going to attend, please let us know. Just like throw a thumbs up emoji. Just that way, if no one responds, like Leah and I will take our Saturdays and do other things. But we're also happy to stick around. So don't feel like, oh, if I'm the only one, like, is it like, please show up. Like, we're just happy to answer questions. So don't be afraid to show up. And also, if you're just like, if you're gonna be like, I have to come at 4:30, just drop us a note and let us know. That way we're not waiting around for an hour and a half for folks. Again, I don't want that to sound negative. Like, I'm happy to stick around, but just if you know that you're gonna show up at a certain time, just let us know. That way we can make sure we're there for you. Cool? All right. Thanks, everybody. And we'll see you all next week.
Thank you.
Thank you.